Hi, my name is Ben Schwartz, and I lead the Human-Centered Systems Engineering team at Monterey Technologies. This is a practical presentation on the human-centered approach and how it can be a force multiplier in your business. This approach ensures that solutions delivered to the field are operationally effective, they meet mission needs, and they fulfill lifecycle concepts. Perhaps more importantly, within the system engineering process, this approach helps to manage cost and schedule risk. And of course, all of these things can be a huge differentiator for a business in the defense industry. So I'm excited to share it with you, and I'm going to start with a case study. You're probably familiar with this system. It is the Stinger Man-Portable Air Defense System, or MANPADS. It was first developed in the late 1960s as a replacement for the Red-Eye system. It was one of the first systems developed from the start with state-of-the-art computer-based modeling and simulation. That allowed the engineering team to model and predict the performance of the system and look for areas where additional technology investment would be necessary to support system performance. They ended up investing in things like improved sensors with better signal-to-noise ratios, better target tracking, and guidance and navigation systems. The result was that the requirement for 60% PK was met easily in developmental tests and evaluation. However, when the system was put in the hands of actual users in operational tests, it fell far short and only reached 30% PK. And that difference is the user. The system was designed by scientists and engineers who were focused on those technology development aspects. However, they failed to sufficiently consider the capabilities of the soldiers who would actually be operating the system in the field. One of the reasons I really like this case study is that the Army conducted a lessons learned analysis and identified a handful of human engineering shortcomings. The key one is that 18 separate steps were necessary to set up and fire the system, and it proved to be too complicated for many of the soldiers in the intended user population. The assumption inherent in that 60% PK requirement is that the user performance would be perfect, and that 60% only applied to the technology aspects of the system. In reality, system performance is a combination of the technology and the ability of the human to effectively implement that technology in their mission. Of course, Stinger has been a successful system for many years, and so we know the eventual outcome. But the system was dogged by testing delays, and those human factor shortcomings took time and money to fix, which delayed getting the system out into the field. It also meant a lost opportunity to identify human factors capability enhancements. These impacts could have been avoided with effective human-centered systems engineering earlier in the program, resulting in better combined human system performance and optimized lifecycle concepts. Understanding the broader context and user needs is what drives us at MTI, and we take a holistic perspective and approach to systems engineering. So human-centered approaches span the entire systems engineering effort. And here I've highlighted a few key concepts from research, analysis, design, and development phases. It starts with a deep understanding of the mission and user needs that's carried through the entire project. And that deep understanding is developed through observation and engagement and input from users and stakeholders and subject matter experts. As an example, Scott Cook, the co-founder of Intuit, was famous for offering users a free copy of Quicken if he could follow them home and look over their shoulder as they installed and began using it. Accounting software at the time, this was the 1980s, was built for big businesses using double entry bookkeeping. There was a gap in the market for software built for personal finances. Scott has an MBA from Harvard Business School. He was not in the intended user population, so he understood the importance of going out and engaging with those users to understand how they would use the product and crafting the product around the needs of individuals and their personal finance goals. The user-centered approach also means moving human factors analyses and trade studies earlier into the process to identify areas where additional investment and architecture decisions can support human performance. As an example with Stinger, instead of assuming that human performance would be perfect, could have identified those things that might have impacted or driven human performance to craft human factors, designs, and displays and controls, decision aids, training, etc., that would have supported human performance. And finally is an iterative design and development process that uses the best human factors, user experience, and software development to iteratively prototype, test, evaluate, and develop the product. That not only feeds back into the design process to help continue to improve the solution, but it provides iterative, ongoing verification and validation to ensure that we're building the right thing, reducing risk, and ensuring that the product will be effective in a mission context. And it can be a force multiplier. One of the ways that this is true is minimizing late requirements discovery and subsequent rework. We've all seen the chart of the cost to fix a defect as a function of time and design maturity. The later you find an issue, the more expensive it is to fix because you've locked in so many of those design decisions already. That user-centered requirements discovery, analysis, and trade studies make sure that you're building the right thing from the start. I can't tell you the number of times I've been on a project where so much work was done to develop a solution based solely on the requirements and other documentation and not engaging with users. Sometimes maybe you might have a subject matter expert to engage. That person might have been out of the field for decades and not understood the evolving nature of the mission and operational needs. So we would get to a user touch point with an exquisite solution only to learn that the requirements had been misinterpreted or not fully fleshed out, or there were some assumed or inherent requirements that weren't discovered. And when that happens, what can you do? It's too late to go back to the drawing board, so you end up patching and band-aiding, forcing users to retrain, and delivering a suboptimal product. Earlier, I mentioned the development of Quicken. Would you rather learn double-entry bookkeeping, having to take a college course in bookkeeping, or pick up a tool that was designed specifically for personal finance needs? And that gets to the topic of mission effectiveness, which is especially important in military missions because they're critical missions that they cannot fail. Our users don't have a choice for what solutions they use. If you have an app on your phone that isn't working for you, you can uninstall it, go back to the App Store, and pick from a dozen other options that kind of do what you need until you find the one that suits your needs perfectly. Our users don't have that luxury. They have to use the system that is available to them. They will make it work because they have no choice, and they'll continue to make it work until they get into a situation where it doesn't work anymore and it all falls apart. Human-centered engineering ensures that the solution is intuitive, robust, and mission effective for the warfighter and for our nation. At the same time, we also have to recognize that the warfighter is the tip of the spear, and there's a whole enterprise behind them to support and train and maintain that system and solution. And those things are all just as critical for the success of the system. It doesn't matter how great the technology is, if it's not ready for battle and doesn't have the right users or enough users available to use it on the battlefield. And finally, all these things can be a differentiator for your business and for your product. As an example, MTI is a subcontractor on a project for Space Force that started as a competitive prototyping effort. Our team was led by a non-traditional defense prime, competing against two major prime contractors. In this OTA competitive prototyping effort, we developed a solution, a prototype that was faced off against those other entrants. Our solution won the down select on the strength of the user experience. Specifically cited that we understood the user's needs and how to support their performance. And we got great marks. And now 2 years later, we're actually getting ready to deliver and deploy that system in a couple of months. And we're really excited because we've been engaging the users every other week, showing them new features and capabilities, getting their feedback, letting them test it in operationally relevant scenarios, and continuing to improve the product. And that system's going to go into operations in a couple of months, and the users are so excited to have it. Because not only are we worried about the look and feel, but also supporting their workflows, understanding how automation and decision aids can help them make more accurate decisions, make them faster, while keeping them in control ultimately of their mission and how they use the automation to support their effectiveness. So I've talked a lot about what human-centered engineering is, but I haven't really mentioned Monterey Technologies, MTI. We provide a full range of human-centered systems engineering capabilities, including model-based systems engineering, digital engineering, and modeling and simulation of human performance. And we do that by bringing together best-of-breed tools from various specialties under the umbrella of human engineering, such as human systems integration, user experience, cognitive psychology, and we also have a particular emphasis on human autonomy interaction. We also have a full stack software development department to realize those designs and collaborate as part of a cross-functional team with our human factors and user experience capabilities. Our experience spans defense services and missions, as well as civil and allied nation organizations. And I'm happy to talk more about specific capabilities, projects, and customers, but really the strength of this approach is that it applies to really any type of project, and it gets tailored based on the specific needs of that project, customer, domain, etc. A key area of emphasis right now is human autonomy interaction. AI, ML, and autonomy are promising capabilities, but there's a sense that we can just throw them out into operations and they'll start providing value. And that couldn't be further from the truth. Right now, we're at a point where humans can outsource some basic tasks to AI, ML. Think of how you might interact with ChatGPT to brainstorm or to write some documents, but still requires a lot of human decision-making and rewriting. As these technologies mature, we need to put a lot of emphasis into how humans and autonomous systems will work together, especially as part of a trusted collaborative team, and especially in complex evolving situations. That's way easier said than done. I've collected a few elements here, critical elements of success that we're thinking about as these technologies develop. And calibrated trust is a huge one. Overtrust pulls the human out of the loop and allows the AI to continue to operate even when it may not be making the best decisions or gets into a situation that it doesn't know how to handle. Just as problematic is undertrust of an AI. There are countless examples of tools that have been provided to human users where the human distrusts the automation and to disastrous effects. At the very least, if the human just ignores the AI and continues to operate manually, then they are sub-optimizing decisions, they're working more slowly, and they're really just not getting value out of all the effort that was put into developing that solution in the first place. But the aspect I really want to highlight is mission command of autonomous systems. This could be the real game changer when autonomous systems can understand commander's intent, understand the implied constraints of a mission, and effectively communicate with other humans as if they were other humans in a team. We're a long way off from that being routine, but we can start developing interfaces today that leverage that mission command approach and help us develop better ways of human autonomy interaction so that we can take advantage of the technology as it develops. A great example is the Army's Human Machine Integrated Formation effort, HMIF, that is experimenting with mixed teams of humans and autonomy, humans and autonomous and optionally crewed vehicles, to better understand how this might work in practice and develop technologies that can realize it. So to summarize, human-centered approaches can be a force multiplier for systems engineering. Aligning design and development to user and mission needs, make sure that you're delivering the right thing while minimizing late discovery and rework and managing cost and schedule risk. It supports iterative verification and validation of the solution to continue to minimize risk, making sure you're delivering the right thing. And finally, it helps you optimize across performance, lifecycle concepts, and costs through application of human systems integration analyses earlier in the systems engineering process. MTI is proud to support other small, medium, and large businesses with our extensive human engineering capabilities. We also have several prime contracts where we can lead the development of an entire solution from this human-centered perspective. I'd love to engage with you more on your particular needs and projects and look for ways that this human-centered approach can be a force multiplier in your business. Please reach out to me on LinkedIn or feel free to give me an email, and I look forward to engaging with you. Thank you.